Questions 21 through 25 on the 2011 Grade 9 Pascal Math Contest. In the diagram, there are 26 levels labeled A, B, C to Z. There is one dot on level A. Each of the levels B, D, F, H, J, and Z contain twice as many dots as the level immediately above. Each of the levels C, E, G, I, K, and Y contain the same number of dots as the level immediately above. How many dots does level Z contain? Well, we probably just have to write out the letters and then write out the numbers. It wouldn't take that long since it's only 26 letters of the alphabet. And we follow their system, which is partially shown. 1, 2, 2, 4, and that's all they show us. But they give us quite a bit of information in the question that each of the levels that are B, D, F, H, J, all the way to Z contain twice as many dots as the level immediately above. Okay, so the first few have already been given, so we just have to figure out the rest. So twice as many dots, right? So that means if this is 2 and this is 4, this will be 8, and this will be 16, and so on, right? So every second one it will double. So this is 32, 64, 128, 256, 512, 1024, 2048, 4096, and then it's 8192, right? And this is what they want us to figure out, Z, but just for the sake of completion, let's figure out all the other ones. The other ones, which are C, E, G, I, K, and so on, they contain the same number of dots as the level immediately above. So this would be 4, this would be 8, this would be 16, this would be 32, 64, 128, 256, 512, 1024, 2048, and 4096. So that really wasn't even necessary, but just for the sake of completion. How many dots does level Z contain? Well, it's 8192. So number 21, the answer is D. Each of the integers 1 through 7 is to be written, one in each circle in the diagram. The sum of the three integers in any straight line is to be the same. In how many different ways can the center circle be filled? Well, we have 7 integers, and we have to place them in such a way so that if you add up any 3, it's the same. Well, first and foremost, what is the sum of all of these if you add them all up? The sum would be 28. So 28 is a number we're going to have to work with. We're going to have a certain number that goes in the middle, so I'll call it the center number, C for center. So obviously this is C. And then we have 28 minus C, and then we have to divide by 3. And I will explain what I'm doing here. Let me just put it all out in a table format. So I'll give you an example, and the example hopefully will explain everything. Let's say I decided I want to put the 1 in the center, right? Let's start with 1. So that means all the other numbers have to be obviously placed around here. But the 1 is common to everything. So all the other numbers have to add up to the same. So if C is 1, then 28 minus C is 27. And that means that I'm going to have 1, 2, and 3 sums. And that's why I've got to divide this number by 3 to figure out in each of those sums. And that's why I wrote this. So divide by 3, and I get 27 divided by 3, and that is 9. So that means that each of these guys, this one and this one, have to add up to 9. Okay? This one and this one have to add up to 9. this one and this one have to add up to 9. So let's fill this in. If this and this add up to 9, one possible way of doing that is a 2 and a 7. If this and this add up to 9, one possible way of doing that is a 3 and a 6. 3 plus 6 is 9. And the only two numbers left are 4 and 5, and those also add up to 9. So it works. It's great. So what they're asking for is how many different ways can the center be filled. So I initially filled it with a 1. Is that the only number I can put in the center, or are there others? Well, there are others, and the system is exactly what I did right here. This is the only way it's going to work. If this number is an integer, it will work. So let's try it. 2. If I put 2 in the center, so we're going to have to erase all of this. 28 minus c would be 26. Then you divide that by 3. Is that an integer? And the answer is no. So there's no way for us to do that, because obviously the sum has to be an integer. Let's try 3. 28 minus 3 would be 25, and 25 divided by 3 is also not an integer. How about 4? This is going to be 24. 24 divided by 3 is 8. So that is an integer. So therefore, in addition to 1, 4 can also be placed in the center. 5 will give me 23. 23 divided by 3 is not an integer. 6, if I put that in the center, that means that's going to be 22. And 22 divided by 3 is also not an integer. And finally, 7, if I put that in the center, I get 21. And 21 divided by 3 is indeed an integer at 7. So 7 could also be put in the middle. So let's do that. Let's put 7 in the middle and illustrate that this works. If 7 is in the middle, then that means this guy and this guy must add up to this number, which coincidentally is 7. Well, how can I make a 7? Well, I could put 1 in 6. And then how about these two guys? I can put 2 in 5. And then here, there's only two numbers left, 3 and 4, and they also add up to 7. So it works. And I'll let you do this guy right here, where you put 4 in the middle and then figure out how to put the numbers. So as you can see, there's only 3 ways to put a number in the center, and those numbers are either 1, 4, or 7. So number 22, the answer is C. An ordered list of 4 numbers is called a quadruple. A quadruple PQRS of integers with PQRS greater than or equal to 0 is chosen at random such that 2p plus q plus r plus s is 4. What is the probability that p plus q plus r plus s is equal to 3? So we have to again make a little table and go from there. So I'm going to do this not super slow, but a little bit slower than what you would probably do it on a math contest. On a math contest, you know, you're going to do this really quickly, boom, boom, boom. But I'm going to do it slower just because I need to explain it, right? So what I'm really doing is making a list of PQRS and trying to figure out what possible values I can have in order for these equations to be satisfied. And really the equation I'm concentrating on initially is that one. First, let me just concentrate on this, and then once all this is done, we'll look at how many of the table values match this criteria, and then we can figure out the criteria, the probability. So this is the equation. 2p plus q plus r plus s must equal 4. So if it does, what are my possible values? Okay, well, let's start. P obviously is an integer, so 2p has to be equal to 4 if everything else is 0, right? And the only value, therefore, would either be 2 for p. So let's start with that. You can't have anything greater than 2 for p because these are all positive. A positive or 0. So if it's 2, these would be all zeros. Okay? So I hope you understand. I'm just trying to figure out values for p, q, r, s. This is the only scenario for p equals 2. If p equals 1, now we got to play with these numbers a bit. Well, we can have 0, 0, 2. That would work. This would be equal to 4 if you plug them all in. If it is 0, 2, 0, that will work. 2, 0, 0, that will also work. If P is 1, you can also have some 1s for QRS. You can have, for example, 1, 1, 0. You can have 1, 0, 1. Or you can have 1, 1, 0. So these are the ones for P equals 1. Now we get to the scenario of P equals 0. And now we've got quite a few that we have to talk about. Let's start with, any of these is fine, but let's start with 4 for S. If it's 4, this would be 0, 0. And then we can also switch the 4 to go here or here. All right, so that takes care of the 4s. Remember, P is going to be all zeros now. Now we can have a scenario of 3 and 1. We can have 3 and 1 like that. Or you can have the 3 and 1 appear in different combinations like this. Or you can have the 3 and 1 appear like this. And so on, right? So they're just playing around with those numbers. So you just write out all the ones with 3s and 1s. And then the last one is if you have 2s for S, for example. If that's the case, you'd have a 2 for the R and then a 0 here. And then, of course, you just put out all the different possible combinations of this, like that. And then the very last ones are if you have some 1s in there. So if you have 1, 1, 2, like that. 1, 2, 1, and finally 1, 1, 2. So this takes care of all the possible values for PQRS that satisfy that. So we have to figure out a probability. So the denominator of a probability is the total number of cases. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I think another 11 here. 13, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So 22 is what's going in the denominator. Now we have to figure out the numerator. The numerator is the number of cases that PQRS, the sum is 3. So which one of these 22 is P plus Q plus R plus S equal to 3? Well, if you look through this, you will quickly be able to figure out that the only ones where PQRS all added up as 3 are just these ones. All the other ones, it doesn't equal 3. It would equal 2 or 4, or probably 2 or 4 are the sums. These ones, however, the ones I just circled in red, are the only ones where the sum of P, Q, R, and S is 3. Now, how many are there? Well, there's 1, 2, 3, 4, 5, 6 of those. So 6 is what goes in the numerator. And there's your probability. And in lowest terms, that will be 3 over 11. So number 23, the answer is B. Let n be the largest integer for which 14n has exactly 100 digits. Counting from right to left, what is the 68th digit of n? The strategy in this question obviously is not going to be trying to figure out the full number, because that would be too time consuming. So what we have to do is look for a pattern. So let's make a table and off we go. In this table we are going to write n. We are going to write 14n, and then how many digits is there in that number? So let's start with the very beginning. If n is 1, well, if n is 1, the number is 14, and the number of digits is 2. And let's go to the very end, instead of writing out every single one. If you get to the very end of the 2-digit situation, you get 98, and that happens when n is 7. And again, we are at 2. Now, when we go beyond n equals 7 into 8, we will get 112, and now this is 3 digits, right? 112 is 3 digits. And then again, go look to the very end. You can just take a calculator, which is allowed on the Canadian exams, take 1,000 divided by 14, and you will get an idea of what n will be. It's about close to 71, and it gives you 994. And we're still in the 3-digit category. But once you go to 72, Now you get into the next category. It's 1008, and now we have 4-digit numbers. And you just keep doing this, right? So take out a calculator, divide by 14, and you'll get a number close to 714, and that will give you an approximation of how close you need to be to 10,000 to get this number. And this is, of course, still a 4-digit number. Now we get into the next category, which is 5-digit numbers. It starts off with 715, and if you do, you get approximately 10010. And then same thing, take a calculator, take 100,000 divided by 14, and you get about 7142. And that's going to give you 99988. So as you can see, I'm trying to get a pattern with regard to this number. Why that number? Because, read the question, n be the largest integer for which 14n has exactly 100 digits. What they're saying is they want 100 digits, so this number has to be 100. But obviously that's way too time consuming, so I have to hopefully get a pattern fairly quickly. So let's continue. That's 5. So the next one, 743, will obviously be the number above that. So that's going to be 00002, and that is a 6-digit number. And then in the very same way, take 1,000,000 divided by 14, and you'll get the approximate value for this number, which is 71428. And that's going to be some big long number, 999992, I think. Okay, so far it doesn't look like there's any kind of pattern, but let's just keep going. Hopefully we'll get a pattern sooner rather than later. And in the same way, now we're up to 7 digits, and of course that's going to be 71429. And it's 1000006. And then same thing, we are now up to 7 digits, right? So 10 million and divided by 14 to get an approximation of what this number will be, and it's 714285. If you take that and multiply by 14, you'll get 9999990. So that's a 7-digit number. And then it's the same scenario, just keep going. 8-digit number. This will be, of course, 714286. And that's going to be 10 and then 000004. And then you take, what are we up to now? 100 million? Yeah, 100 million divided by 14. And you get 714285.7. And if you do that, it's 9999998. So at this point, and if you're doing this on a calculator, you actually can see it. There's a little bit of a pattern. You may not see it, but if you keep going, you will. Right there, 714285, and then 7, and then it just keeps going like that. 714285, 714285. Now you say, well, I don't think that is obvious. Well, if it's not obvious, then just keep going, right? I mean, it's number 24, so it's going to be pretty challenging. If you keep going, and I'm just going to concentrate on the last numbers, right? I'm not going to do this first one. I'm just going to write the last numbers for each of these. This one, if you do it for 9, it'll be 714285.7, and then 1. If you do it for 10, it will be 714285.714. If you do it for 11, same thing that I've been doing the whole time. Nothing, no fancy tricks. I'm just doing the exact same thing. It'll be 714285.714.2. If you do it for 12, it will be, well, hopefully by this point you get it, 714285. and 71428, and so on, right? And I'll just do one more, 13. It'll be 71428571425. 71425. Okay? So by this point, hopefully you are convinced that yes, I understand the pattern. It's just 7142855 repeating itself. So let's extrapolate this. Obviously, we want to bring it to 100 because that is what the question is asking. So every 6, it just repeats, right? So for example, it first was 7142855 when the digits were 7. And then if you add 6 to that and get to 13, it repeats again. So every 6 it repeats. So that means if you keep adding 6 to 13, it will just keep repeating. So if I get up to 97, it will basically be 7142855 repeating itself again and again. And how many times? Well, for 7, how many times? It was once, right? For 13, it was twice that it repeated. Well, for 97, all you would have to do is just take 97, subtract from it 1, and then divide by 6. And you get 96 divided by 6, which is 16. So it's basically just repeating itself 16 times. 7142855, 7142855, and so on 16 times, right? So I hope that makes sense. So now we get to 100, which is what they want you to figure out. Well, it's only 3 more than 97, so it would be 7142855, right? Repeated 16 times, just like 97. So ... 7142855, and then 3 more digits. So those 3 digits would be 7, 1, and 4. This would be the number that they're asking for. That's the n, that's the largest n, for which 14n has 100 digits. Now, unfortunately, we're not done with the question. We have to now count from right to left this number and figure out what is the 68th digit of n. Okay. Well, that shouldn't be too big of a deal. Let's write this out. 7142855. And of course, it just repeats itself 16 times. 7142855, 7142855, and then 714, right? So that's the number. Now we have to count from right to left. So we're going that direction. And we have to figure out the 68th number. Okay, well, this is the first one, second one, third one, fourth, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, right? I'm not going to obviously count to 68, but one thing I notice is that every time it's a multiple of 6, it's a 2. So eventually I'm going to get to a point where I get to a multiple of 6 that's very close to 68, right? Because 68 is the digits that we're interested in. So that's going to be 66. So eventually you're going to get to 66, and that's going to be a 2, just like all the other multiples of 2. Then just keep counting, 67, and then 68. And the 68th digit is a 1. And that's the answer to the question. So number 24, a very cool question. The answer is 1, and that is choice A. Dolly, Molly, and Polly each can walk at 6 kilometers per hour. Their one motorcycle, which travels at 90 kilometers per hour, can accommodate at most 2 of them at once and cannot drive by itself. Let T hours be the time taken for all 3 of them to reach a point 135 kilometers away. Ignoring the time required to start, stop, or change directions, what is true about the smallest possible value of T? We have to develop a strategy to figure out what is the way that they're going to travel. And I think that is the most challenging part, figuring out the strategy. Once the strategy is figured out, then the math is relatively straightforward. So here is the strategy. So I'm going to draw a few lines and then explain it. So the three friends, D, M, and P, all obviously start off at the start, and this whole distance is 135 kilometers to, I guess, the finish line. We can call it finish. And the strategy is as follows. First, two of them, let's say Dolly and Molly, get on a motorbike, and they go all the way to a certain point. They get to here. So D and M arrive here. Meanwhile, Polly is walking. So Polly is not staying here. She's walking. So she's somewhere around here. Okay? Now, at this point, we don't know any of these distances. So I'm just going to label this distance X. It's the distance from that point to the finish. Now, this is a very important point. That is what you call a drop-off point. That is where Dolly drops off Molly. And then Molly starts to walk in this direction. So Molly will start walking toward the finish line. But then Dolly goes back to pick up Molly. Okay? So now Dolly's coming back. And by this point, Polly is walked till about here, right? And then Dolly comes back to pick her up. So this is now a pick-up point. Now the distance that Polly has walked from the start to there, I don't know, so I will call it Y. Okay? Meanwhile, Molly is still walking. She is probably pretty close to the finish line. Not sure where, but somewhere around there. Then Dolly picks up Polly and then drives her back on the motorbike. So then they all go back together, and eventually they end up at the finish line. So they all end up back at the finish line, P, D, and M. Okay? And they all arrive at the finish at the same time. So let's figure this out. And we're going to use, of course, that formula, speed is equal to distance over time, and any variation of this formula, such as time is equal to distance over speed. So let's figure this out. Let's call this first scenario T1, and then this second scenario we'll call T2, and then this final scenario we'll call T3. And then, of course, the T is the time taken for all three of them to reach point, I guess the finish line. So that T that they're asking about that's in the answer choices is really T1 plus T2 plus T3, because all of them have to reach the finish line. So here we go. What is T1? Well, it's distance over speed. And for this distance, it's from there to there. Now the whole distance is 135. And from here to here, I have labeled that as X. So that distance that the two friends on the motorbike travel from there to there is really just 135 minus X over 90, which is the speed. And then for Dolly, which is the first friend that I really am talking about, T2, her T2 is basically going from that drop-off point back to the pickup point, right? She was here, but then now she's traveling to there. So she goes back like that. So that distance is basically 135 minus X minus Y. And again, over 90, because she's still on the bike. And then the last distance is when she goes from the pickup point, right here, all the way to the finish line, and ends up here. So that is going to be 135 minus Y all over 90. All right. So I hope that makes sense. Those are the three times for Dolly. And the total, of course, we need to figure out. But the only way we could figure out the total is if we had actual numerical values for X and Y. And we don't. So what do? Well, if we don't have that, we have to come up with new equations. We have to come up with additional equations that will allow us to figure out the values for X and Y. And how we do that is by looking at the other friends. We'll look at Molly, and then we'll look at Polly. So in the very same way, let's look at Molly. What is her story? Well, Molly initially was on a motorbike until the drop-off point, so that's going to be 135 minus X over 90. Now let's talk about T2 for Molly. Interestingly, for Molly, T2 and T3 is sort of the same because that whole time she's just walking. So we actually don't even need to worry about two different times. We should just concentrate on her second phase, which is just walking, and that's just x over 6. The distance is x and the speed is 6 because they're walking at 6. So that's all there is for her. And then Polly, her T1 is that initial phase where she's walking. So that's actually going to be just y over 6. And then her final phase is when she's on the motorbike and going all the way to the finish line with Dolly. And that is 135 minus y over 90. So there you go. This is a breakdown of all three friends. Now we still haven't figured out the numerical values for x and y, and that's obviously required. So how do we do that? Well, we do that by looking at the times and comparing them. So for example, after this drop-off point, the time it takes Molly to go from the drop-off point to the finish line is this right here, x over 6. But that is the same amount of time it takes Dolly to go all the way back to the pickup point and then back to the finish line. So remember, they all arrive at the same time. So that means this is equivalent to this plus this. Okay? That's very important to this question. So 135 minus x minus y plus 135 minus y, these are both over 90, is equivalent to x over 6. Those times are the same. And in a very similar way, we can compare Molly and Polly. Comparing Molly and Polly, their total times are the same. The time it takes Molly to be on the bike and then walking is basically her entire journey, is the same amount of time as the entire journey for Polly, which is an initial walk and then a motor ride. So that means that 135 minus x over 90 plus x over 6 is equivalent to y over 6 plus 135 minus y over 90. So there we go. We got two equations, two variables. We can now solve for x and y. So let's proceed, and then we can come back and figure out the time, which is right here. Well, this equation, let's start with that one first. Let's multiply through by 90. That will get rid of the fraction. So we have 135 minus x minus y plus 135 minus y. If you multiply this by 90, it becomes 15x. And then let's put everything on one side. 270 minus 16x minus 2y is 0. So if I isolate for y, I get 270 minus 16x. Divide through by 2, you get 135 minus 8x. Okay, let's solve this one right here. Divide or multiply through by 90 and you get 135 minus x plus 15x plus 15y. And that's going to be just 135 minus y. So the 135's cancel, and we got 14x is equal to 14y. So that means x is equal to y. Oh, okay, interesting. Substituting that back into here, and we got 135 minus 8x is equal to y, but y is equal to x. So that means 135 is equal to 9x, and therefore x is equal to 15. And that means y is equal to 15. Okay. There we go. I just got numerical values for x and y. Now I can figure out my times. So keeping this in mind, that t is equal to t1 plus t2 plus t3. Let's just use Dolly since Dolly has t1, t2, and t3. So that's going to be 135 minus x over 90. Well, x is 15, so that's going to be 120 over 90. T2 is this 135 minus x minus y. Well, x and y are both 15, so it's 135 minus 30, so 105 over 90. And then finally, this guy, 135 minus y, so that's 120 over 90, since y was 15. And that is in terms of decimals, 1.33 plus 1.166 plus 1.33, and if you add it all up, it's approximately 3.83. So that is the shortest. The strategy was to figure out the shortest, 3.83. And therefore, t would lie in which interval? A, right here. So like I said, the strategy, which is this diagram right here, is the challenging part of the question. Once you get the strategy, then you just use this formula to figure out what is the smallest possible value for t, which is the time. Number 25, the answer is A.